All right, so we're doing, is this us, TicTacToe? Yeah, this is us. Okay, so we're trying to make this match up to what's happening on um, Alice the best we can. So I'm actually going to change this file up a little bit. I'm going to call this guy, I'm going to do what's called refactoring, which is going to just change the name of this. So I'm going to this, instead of calling this scene, I'm going to call this driver. And just hit finish there. And it's just going to update everything inside here for that. And then what we're going to do is we're going to create a, so just to kind of go back, we'll say system.out.println. This is our hello world program. So all programs begin and end with main, something I've kind of said before. We wrote a function last time that did something. We're going to move this guy here in a second. But just to match this up to Alice, when we look at Alice over here, we have our instance of the scene, which is the container that holds everything else that's going on inside of our application, right? That's the top level thing. So we have a scene. Inside the scene, we have one instance of our Mad Hatter. We have 9 instances of our Monkey Kings, and each one of those has procedures and functions and properties and that jazz, right? But at the top level, we have our scene. So that's it. We're going to think of our scene as an object. So we're going to go ahead and build a scene object just to make this match up. So I'm going to right-click on over here. You can either do it on source or under default package. It doesn't matter. We'll right-click. We're going to say a new class. And we're going to call this guy the scene. Okay. And so as of right now, that's all this guy is going to do. And then what I'm going to do is I'm going to take the static off our myFirst method. And then we're going to cut it out of here. I'm not going to talk about static versus non-static right now, but there is a difference. It's important, but not to us right this second. And I'm going to paste this guy in here. All right. So just as we had in Alice, all our scene had a method called myFirst method. That was something that was provided to us at the scene level. So this was a procedure called myFirst method, and that is something that does not return a value. So now we go in here, we see that this guy, this method does not return a value. The syntax for methods in Java is return type, followed by method name, followed by parameter list. And then opening parenthesis, body, closing, or opening curly brace, body, closing curly brace. So this is our general syntax for functions and procedures. Procedures would have a return type of void. Function would have a return type of something other than void. The punchline. All right, but just to match up to what we have in Alice, here's our myFirst method. Go back to Alice here. Right now, our myFirst method does what? It creates a collection of Monkey Kings and does a bunch of stuff. But maybe in the beginning, our first method could just ask the user for some information or something like that. We're just going to have this guy say, welcome to the scene. Get rid of this for a second. And we'll have this guy, our myFirst method. Welcome to the scene. Okay. And now we'll go back to our driver. So the driver drives our program. That's why I like calling that guy driver. All Java programs begin and end with main. So when we run this guy, it is going to immediately jump into the main program here and start cooking. So what we're going to do is we're going to go ahead and create an instance of the scene. So we'll say scene s is equal to new scene, just like that, and then we'll say scene.myFirst method. So that'll actually call that first method to get the ball rolling. That make sense? And we should see that back here in Alice. at the event listener level. So this is, think of this as our driver. And our driver created our scene. Once our scene was activated, it went ahead and called my first method. So that's kind of gets the ball rolling. So that's the best we can do right now to kind of make the exact equivalent without starting to write Alice. is kind of the idea here. All right, so now we think about our, if you think about the actors that are going to go into our scene here, we're using many of them here in our main, but we're going to have our Mad Hatter and we're going to have our Monkey Kings, right? So let's deal with our Monkey Kings first. So if we look at Monkey King, we notice that Monkey King has a couple of properties. One property is who moved me. Another property is whether or not I'm shrunk. So this was a number, right? Who moved me? It was what, -1, 0, or 1? I think we had it. So we had this guy as a number. Is shrunk was a Boolean. And then original paint was a color. Original paint's not going to make a whole lot of sense in our text-based Java implementation of this, but it'll work out okay for us. You'll kind of see how this works. So we'll go ahead and we're going to create our Monkey King. So we're going to create another class here, and we're going to call this guy Monkey King. All right, and as we said before, a Monkey King has who moved me, is shrunk, and let's skip. Well, actually, we'll leave original paint for now. We'll fake it. We'll just use it as a string or something like that for the color. So original color will be normal. That's going to be his normal color, is the normal Monkey King color. All right, so we're going to have to give ourselves 3 properties in this Java. In Java, these are called fields. All right, so we're going to have 3 fields. One of them is going to be who moved me, so int who moved me. Then we're going to have, and who moved me, I think we defaulted to -1, right? And then we're going to have another one, Boolean, is shrunk. And that guy is going to be equal to false initially. And then finally, we have original paint. And let's make that guy a string, original paint. So we don't have a paint equivalent here. So we'll say string, original paint, and we're going to call this guy normal. Okay, that's the original paint for a Monkey King. All right, so we have that guy. So now let's go back and look at Alice and see, what does my first method do? My first method goes ahead and it creates a bunch of Monkey Kings for us. Okay, it links to these Monkey Kings that are in the scene here. So when the scene is first born, a whole bunch of guys are born here, and my first method collects those Monkey Kings into an array. Okay, so this is an array of Monkey Kings. So we're going to go ahead and we're going to make the scene, we're going to make my first method aware of an array of Monkey Kings. So we have a local variable that belongs to my first method called the Monkey Kings, and it's equal to an array of Monkey Kings filled up with a bunch of Monkey Kings. Okay? So we're going to go back into our scene. Here's my first method. So we're going to go ahead and we're going to create an array of Monkey Kings. We called it the Monkey Kings, is that right? The Monkey Kings. So we're going to have a Monkey King array called the Monkey Kings. And this guy is going to be a new Monkey King array. Actually, let's match this directly up. So our scene has 9 Monkey Kings, right? Called MK1, MK2, so on and so forth. So let's go ahead and, before I write this in, let's define in our scene those 9 Monkey Kings. So we're going to have monkey king mk1 is equal to a new monkey king. mk2, 3, 4, 5, 6, 7, 8, 9. All right. So there is that. So those are our 9 monkey kings that are born when the scene is born. All right, I'm purposely omitting something called a constructor right now because we're trying to literally map Java directly to Alice right now. Then we'll start filling in some blanks. But, you know, so when a scene is born from our perspective, it comes with 9 monkey kings. It's also to come with a Mad Hatter, but we haven't put him in there yet. Well, let's go ahead and put him in there just so we'll have to build another class for our Mad Hatter. So there's the Mad Hatter, and we'll come back and figure out, well, actually, let's just look real quick. What do Mad Hatters know how to do? Oh, he really knows how to do nothing, right, at this point? So good, simple. That's our Mad Hatter. He actually knows how to do a couple of things because he inherits a bunch of stuff from his parent, which I believe was, what, Biped? All Mad Hatters are also bipeds. So if we are really connecting the dots here, which I guess we can do, we're going to have a biped class, if you remember correctly, that here's our bipeds. We have 2 bipeds in here. One is a monkey king and one is a Mad Hatter. And bipeds have a whole bunch of functions. For instance, they have get paint, get opacity, get width, get height, get depth, get Boolean from user. They have all these abilities. That makes sense? So if we were really writing this, and we'll only fill in the biped stuff that we actually use, but I'm going to go ahead and create a biped class as well. So we'll create a class called biped. And I'm not going to put anything in here yet. We'll add the couple of functions that we rely on from bipeds here in a little bit, like asking stuff from the user, that kind of stuff. We'll put it in there. But for right now, just to show the inheritance model in, let me open this up. Oh, wrong guy there. To show you the inheritance model in Java. So if we look at in our Alice world, okay, at the top level we have something called a biped, and well, in our top level, actually I think there's things above biped, right? I think if we go back into Alice, we go to scene setup, I'm pretty sure we can access them down here. Yeah, so here's all classes. So we have, yeah, so it would probably, Alice would probably look like this. Let's go back to that. So we would have at the top level, we would have just something called an object. All object-oriented languages are going to have that. Then underneath that, we're going to have several objects. So we have a biped. We have, let's go back here and then get to the right place, a flyer, a prop, a quadruped, just call that a quadped so it fits almost, and swimmer and transport. All right, so all of these classes are objects. So we have this top level object, and that provides something in Alice. We'll kind of talk about it in terms of Java, as right now we're making this weird cryptic transition, right, between these two things. So in Alice we have an object, and underneath object we have these 6 object types: bipeds, flyers, props, quadruped, swimmer, transport. Realistically, Alice probably calls these these guys something else other than object, and provides some sort of capability to every single one of these guys that's consistent across them. So we have our object, we have all these things, and then underneath biped we have a monkey king, and we also have a Mad Hatter. All right, so monkey kings and Mad Hatters are bipeds, which are objects. Okay, flyers are objects, props are objects, quadrupeds are objects, swimmers are objects, transports are objects, and each one of these guys has stuff underneath them, right? So this is kind of the inheritance model in Alice, where a Mad Hatter gets everything that a biped gets, which also gets everything that a generic object gets. Okay? So both of our monkey kings have some special stuff in among themselves. So we've written some procedures and functions for monkey kings, and we've written some properties into monkey kings, which differentiate them from Mad Hatters. But both of these guys get everything that bipeds create. All right. So we're going to go ahead and we're going to create this same link here in our world. So we're gonna generate that part of the inheritance model. Okay. So I'm going to purposely expose something that is hidden for us by default in Java. Remember when we talked about the evolution of our languages and we went from C++ to Java? Something we mentioned is that C++ lets the programmer make bad decisions. Okay, they allow us to pass the house instead of giving somebody the address to the house, that kind of thing. Java tried to fix this by making a lot of those decisions for us, and one of the ways it did that is by hiding stuff from us, because it just chose to do certain things for us. So one thing that's hidden here is something that says extends object. Okay, that was invisible code there. I promise you it was there. I've written it in. It will still work with it written in. No harm, no foul. So a biped is an object. A monkey king extends biped, as does a Mad Hatter. Okay? So just by putting in those couple of lines, we have functionally connected Mad Hatters and monkey kings to bipeds, which are functionally connected objects. Make sense? All right. Now let's start filling in the gaps here. So we go back to our scene. Specifically, we go to my first method, where we're supposed to build a collection of monkey kings. So we're going to create a monkey king array, and filled into this guy is going to be mk1, comma mk2, mk3, 4, 5, 6, 7, 8, 9. All right, like that. So now we have our array of monkey kings. All right, so we've kind of mapped this to what we have in Alice. So let's go back to Alice here. Specifically, let's get to our code, and we're back at my first method. So we have our monkey kings. Now we want to go through each of those monkey kings, and we want to call a procedure of that monkey king called set original paint. Okay, now I suspect that in Alice, set original paint is something that's actually at the level above biped. it's probably at this level here. But since we didn't build in this level here, since we're only kind of working in this little world right here, I'm going to assume that's something that Biped provides us. So that Monkey Kings and Mad Hatters both have the ability to give us their paint value, something like that. All right, so we're going to go into our code here, and we're going to go up to Biped. And we're going to put a, let's see, what's it called over here? It's just called get paint. Yeah, get paint. So we're going to go ahead and we're going to create a string in Bipeds called paint. All right. And we're going to set this guy to normal by default. All right. So we have string paint normal, and then we're going to go ahead and give ourselves a function in Biped that returns the paint called getPaint. All right, we're gonna build this functionality into our Biped so that all Monkey Kings as well as Mad Hatters would have that ability. So just like before, we're going to say we have a function that's return a string. It's called getPaint, and this guy's going to return this dot paint. So this is our opportunity to start seeing that this dot stuff. That is, return the paint value of this particular instance of Biped. So right now in our scene, we actually have 10 instances of Biped. Our scene. Actually, I'm lying. We have 9 right this second. We're going to go ahead and put a Mad Hatter in here. We'll call that guy MH, and he's going to be a new Mad Hatter. Okay, so now we have 10 bipeds. Here are 10 separate variables. Each one is an instance. Well, these are instances of Monkey Kings, which are instances of bipeds. This is an instance of Mad Hatter, which is an instance of biped. So inside of each of these guys, there is a variable called this. And that variable is how that particular instance refers to itself. So when this function, getPaint, gets called from one of those Monkey Kings or one of those Mad Hatters or any other kind of biped, when I say this.paint, I'm saying give me that particular guy's value of his paint variable. Okay? So we're kind of faking biped here. So all bipeds can now get us the paint. And what does Alice say we should be doing right now? It says we should going through all of our Monkey Kings and making sure we set the original paint to whatever the original paint value. Remember, all of our Monkey Kings remember their original paint. That's what we did right here inside of Monkey King. We decided that all of our Monkey Kings know how to have their original paint. And specifically, all Monkey Kings know how to set their original paint. That's a procedure, something that returns no values. So we're going to go ahead and, since original paint was something that's specific to a Monkey King, that procedure for setting the original paint also was created specific for Monkey Kings, not to all bipeds. So we'll go ahead and write this procedure. Procedures do not return a value, so that's void. Set original paint. And this guy is going to take a string, we'll call it string paint color in as a parameter, and we'll say this dot original paint is equal to paint color, like that. Okay, so now Monkey Kings now have a procedure called set original paint that takes in a paint color and goes through and sets their original paint value, which we defaulted to normal. In the event that we forgot to set it. But we need to set that value in any case. Make sense? So what did we do back in our scenes, my first method? We go through all of our Monkey Kings. calling each individual Monkey King's set original paint procedure, passing it the current Monkey King's get paint, which it receives from the Biped class. So we're going to say for MK in the Monkey Kings, and this is going to be a Monkey King MK. We'll say MK dot set original paint to MK dot get paint. All right, so we've built up the correct functions and procedures there to allow us to create the equivalent line of code from Alice in here. Make sense? So far, so good. So for each of these Monkey Kings, we'll set their original paint value equal to whatever their current paint is. That is the paint that was originally provided to them by the Biped class. All right. Next thing, we're going to go ahead and our myFirst method has a variable called keep playing. That's a Boolean that we're going to set to true. So we're going to go ahead and define a variable. So now we go back to one of our very early slides here. Let's go all the way back to the beginning. We talked about how human beings solve problems. Specifically, we said we use our memory, asking questions, and repetition. Specifically, we had the mapping. Memory is done through variables, asking questions is done through conditionals, and repetition is done through loops. Every single programming language we ever run into will have facilities for these three things. We've seen these facilities in Alice, and now we've already started seeing these facilities in Java. So we just wrote a loop that loops through all the Monkey Kings. Okay. We have already created a couple of variables, and we're going to create some more. And pretty soon we're going to be asking some questions as well. All right. So any new language that we're going to learn, once we have computer programming as a skill set, if we can learn how to do these three things, we can now solve a large classification of problems in that new language. All right. So that's where we really want to focus on computer programming as a skill set thing. Right here, hopefully we're seeing that we are literally mapping the Alice way of doing things directly over to Java, and so far it looks pretty similar, right? We're seeing a little bit more of the wires, right? Because Alice does so much for us, which sometimes is frustrating because you have to do things the Alice way, and the precision of hitting the drop downs is frustrating, but but in any case, what's funny is most of us are going to end up thinking Java is far more difficult. Where I'll stumble over Alice all day long. Well, I'm pretty solid with Java. We're not going to have a whole lot of similar issues we have with Alice and Java. But in any case, we do see more of the wires in Java, right? We're seeing the structure that's happening underneath the hood there. All right, so let's go back here. So next thing we're supposed to do is we're supposed to create a variable called keep playing and set it equal to true. So that guy's going to be Boolean. So variables in Alice, and we've already seen this is a variable, this is a variable, this is a variable. So I'll just do our generic syntax for variables after this. So generic syntax for a variable is the type followed by the variable name equals value. So we can call this the initial value using Alice lingo. Okay? So we're going to go ahead and create a Boolean. So this guy is going to be a Boolean variable. And if you remember back, we talked about strongly typed versus weakly typed or loosely typed languages. Strongly typed languages are languages that require us to define the kind of value a variable is built to hold. Weakly typed or loosely typed languages do not. Alice, strongly typed. Java, strongly typed. Mostly because Alice is written in Java. All right, but both of those, when we created our variables, we had to specify the kind of value that will be stored in that variable. Okay, just like we're doing now. We're specifying that the variable we're about to create will hold a Boolean. Its name should be keep playing. And we'll start that guy off at true. That's going to be his initial value is true. All right, so notice we have this kind of a common syntax in Java that every statement ends in a semicolon. Now, one thing we need to be careful about is some risks we have in our programming languages, some things you're going to run into in Java. And I'm going to say this in the most memorable way I can. That way, it'll be in your head. We get curly brace diarrhea. Okay, we also get semicolon diarrhea, or sometimes constipation. One of the two. So what happens with beginning programmers is when in doubt, they throw extra curly braces in there. That's going to lead to all sorts of problems. All right. So one thing that I do, and you maybe have already seen me do it. Let me just take. I'm going to steal that line real quick just so I can rewrite it. And Eclipse helps with this, because keep in mind that Eclipse is what's called an IDE, an integrated development environment. This is a text editor on steroids for writing programs. Right? When you went to eclipse.org, you saw that there's a version of Eclipse for different languages. All right? It was originally created for Java, made by IBM, and then as people became used to using that tool, they said, oh well, why can't we use Eclipse to handle other programming languages? Similarly, you probably saw it pop up on the screen before. This is a text editor called Sublime that has a whole bunch of different languages built into it. It's not as full-featured as Eclipse. It doesn't let me run the program directly in there. It actually might, sort of, for some languages, but it tries to do code highlighting for me. It tries to do auto indentation, that kind of stuff. So it has some of the features of Eclipse, but supports a zillion different languages. All right, so this is another tool that's effectively a specialty text editor for doing programming in general. Similarly, here's the equivalent tool. This is Android Studio using Java as well, but this guy is built for making Android applications. So here's building an interface for Android, and this stuff is built into it. So the idea here is that every IDE is going to have tools that hopefully make your life easier. This is the Alice IDE that has all the Alice crap built into it. All right, so we can do the drag and drop stuff, and everything else hides behind the scenes. All right, so Eclipse is not the only way to write a Java program. I can come out here to the terminal, and let's just go. I'll just go back to my thing here. So let's do vi driver.java, and we'll do public class driver, public static void main, string array args, system.out.println, hello world. And so I just wrote this whole program. Now it doesn't, if I leave that out and in Eclipse, I'll start having stuff underlined in red right now. This text editor isn't going to do this. This is a super old text editor called VI. It's a Unix text editor. So this guy is not an IDE. It's just a plain Jane text editor that I happen to be using to write Java code. All right, so I can save this guy, and I can go out and I can compile. So this is equivalent to hitting that play button in Java. So I can compile my program first. So there's my driver.java. I'll compile that. And now it's decided everything was fine. And what it just created is another file called driver.class right here. That's my Java bytecode, if you remember from those slides. Okay? And now I actually run that Java bytecode through the Java virtual machine, which is just the Java command. The javac command was Java compiler. That's what that guy stands for. The Java command is a Java virtual machine, and I'll just run driver, and there's my hello world. All right, so we don't need Eclipse to do Java. Eclipse is just a power tool that we're leveraging to help us do Java. Make sense? Now, one thing that would be very helpful for you, and I very likely will quiz at some point, and it will almost definitely make its way onto the midterm, is write an error-free hello world program. What's highlighted right there. Right? Every single Java program you ever start writing will always start this way. Couple of things that could change is instead of calling the class driver, you might call it my program, or whatever is making sense for whatever you're working on. And you can also change the word args to something else like elephant or something like that. Okay? But I would commit this code exactly to memory. Now, I'm not advocating that you should memorize programming, because programming is a problem solving. It's an active thing. But at the same time, we have to have a starting point. Okay? And this is one of those things that we use every single time we sit down to write a Java program. So it's going to be beneficial to us to be able to write this error-free. That means no missing semicolons, no missing double quotes. Everything is capitalized the exact same way. Java capitalization is important. Every programming language capitalization is important. All right, so when I say error-free, I mean absolutely perfect. So get used to writing that down, drill it at some point. My guess is, just given time frame here, since our midterm will be on Wednesday, and we'll talk about it on Monday, that the first time this guy makes an appearance will be on the midterm. But there will be a question on the midterm. And typically I have like 10 questions on my exam, so it'll be 10% of the grade. And that question will be write an error-free hello world program. So if you can spit this out, that's the worst case you'll get on the exam is a 10. Okay, so it could be worse, right? All right, so this would be a good thing to learn. And what I'll do here is I'll copy that. Open up Slack here, just so you have easy access to that guy. And we'll go into CSC200. And we're going to create a snippet. I'll paste that guy in there. Hello world Java, and I will create that snippet. Alright, so now you can see that whole thing. I think you can double click on it and see the whole thing, whatever. Oh, whatever. All right, so in any case, that's the code. If you memorize that, that's 10% on the exam. Make sense? Okay, that will do you good in the future. It's not just busy work, I promise. All right, so we're going to have our, I need to put this guy back in here. So for instance, one thing I was going to show you, because we were talking about diarrhea, right? Specifically curly brace diarrhea. Often when I create an opening curly brace, and you probably just saw me do it, I didn't even think about when I was doing it, but when I write an opening curly brace, I immediately press enter and put the corresponding closing curly brace. Eclipse will do that for you. All right, so Eclipse will put that line in there for you. So now I'm going to, actually let's just backspace here and put those guys back in. So that's back to what we had before. So if I'm typing this out in something other than Eclipse, if you get into the habit of always having a closing curly brace for every opening curly brace right off the bat, then pressing enter in the middle and start building your sandwich, that's probably a pretty good habit to get into. All right, so we have our Boolean keep playing is equal to true, just like Alice says. Then we go ahead and tell it to play tic-tac-toe. Oh, well, who is playing tic-tac-toe? This is playing tic-tac-toe. And who is this in this world? It's the scene. All right, so the scene has a procedure called play tic-tac-toe. So we need to go and add that procedure to our scene. So here's our scene. We're going to add a procedure below here, and it's a procedure, so it's going to be void play tic-tac-toe. And this guy took in some parameters, right? No, we didn't, because we put our monkey kings up there. Good. Actually, is that true? Well, he took no parameters, so that's fine. So we're going to play tic-tac-toe, and we'll just open, close like that. So let's go see what that guy's supposed to do. All right, so we're going to go into our play tic-tac-toe function, or method rather. This is of the scene. Here's play tic-tac-toe. All right, so the first thing this guy did is it went ahead and created his own array of monkey kings. Probably should have passed it in, but we didn't. So, so if we're trying to make this identical to what we were dealing with before, we're going to rebuild our monkey kings array called the MKs. So I'm going to actually steal it from here. We'll paste it in here, except this guy's not called the monkey kings, he's called the MKs. All right, so a little bit of a waste because we had already built it once. We could have passed it in or just made it global, but we didn't. All right, so there's our MKs. And then we go ahead and we set a, we create a variable called pause of type whole number and start equal to 0. So this is going to be an int pause of type whole number. Well, type int in this case, which is equivalent to a whole number. Okay, we'll start that guy off at 0. Then what do? Well, we're going to ask our Mad Hatter to say something. Okay, so it's going to say, let me set up the board. All right, well, let's go in here. And it looks like our Mad Hatter is called, is actually called Mad Hatter, not MH. So this is Mad Hatter there. And Mad Hatters need to be able to say something. That's something that all bipeds can do, right? All of our bipeds know how to say something. So we'll go ahead and we're going to go into bipeds. And we're going to create a procedure called say. And this guy will take in a string message. And we'll say system.out.println, whatever the message is. All right. Then, so now a biped knows how to say something, which means that Mad Hatters and Monkey Kings also know how to say something. So what are we supposed to do? We're supposed to tell our Mad Hatter to go ahead and say something. All right, now this stuff's supposed to happen together. I'm not going to... That deals with like a multi-threading type thing. Allow me to leave that out right now. That'll complicate our code more than it needs to be complicated. Since we're not having to deal with that time limit of things taking time while our guys are shrinking and changing colors and stuff like that, we won't notice. Okay? But when we said do together here, we wanted this stuff and this stuff to happen at the same time so there wasn't some sort of weird delay. So we're going to go ahead and ask our Mad Hatter to say, let me set up the board. So we'll go back here to our scene. In TicTacToe, we'll say this dot Mad Hatter dot say, let me set up the board. I don't remember how many exclamation points we had there. Doesn't really, yeah, 3. Okay, stay consistent. All right, let me set up the board. All right. So let's just kind of get the ball rolling here and see this guy actually work up to this point. So we should be able to, and actually just for the sake of visually seeing this right now, I'm going to say system.out.println this dot toString concatenated with maybe a colon. Actually, let's put a little arrow in there for kind of who said this. This is going to look like a crazy looking memory address, but it'll have the word Mad Hatter in there. So we'll be able to identify him as being a Mad Hatter that's actually saying this. All right. Since we're not going to have the nice Alice visuals. All right, so Mad Hatter will say, let me set up the board. This is in Play TicTacToe. Play TicTacToe actually got called from my first method, so we need to go ahead and put this guy in there. We'll say this dot play TicTacToe. So we'll go through my first method. We'll create an array of monkey kings. We'll set their original paint values. We'll create a variable called keep playing, and then we call play TicTacToe, which is this guy down here, which resets up an array of monkey kings as a local variable here. Has another variable called pause, starts it off at 0, and then tells the Mad Hatter to say something. All right, so that's what happens in our program right now. They go back out to driver. Notice that driver is pretty slim, right? We have our scene, and we tell our scene to call the initial method, my first method. So what we should see on the screen as output from this guy is our Mad Hatter saying, let me set up the board. So there's our Mad Hatter, let me set up the board. All right, and this is his unique memory address, if you will. Okay, so now that we have that, what's this guy supposed to do next? This guy is supposed to go through all of our monkey kings. And actually, we wrote this a while ago, so this is before we actually knew how to do the for each thing. So we'll write this while loop. So we're going to say while pause is less than 9. So this will be a last thing we will do today. So this is in our scene, play TicTacToe. While pause is less than 9, which is our number of monkey kings. What are we going to do? We're going to say the MKs at bucket pause dot shrink. Okay, dot shrink. So what we're going to need to do is, I'll put some asterisks here. We need to write the shrink method. So this is kind of where we'll have to start next time. And then we'll say pause is equal to pause plus 1. And that will make it match up to what we have in here. Make sense? All right, so actually this will be a good idea. So rather than giving you specific homework for the weekend, why don't we do a quiz on Monday in preparation for the midterm? So we'll do a Hello World, Perfect Hello World program quiz on Monday. So that's a free quiz grade too. But you can't miss anything. Even a semicolon is a 0.
It's all or nothing?
It's an all or nothing thing.
It can be written on a piece of paper.
Written on a piece of paper. So practice. Capitalization, all the opening curly braces, preferably the indentation too, but I won't take off for that. So you should get used to writing structured code. But no missing semicolons, no miss upper lowercase. Should all be there perfectly. So drill that into your soul over the weekend. And I'll see everybody on Monday.